you started out in physics, you've got the classic, right? The quantum physics, or is that the best way to describe it? Kind of not really challenges. Well, I guess challenges the classics because one is more material and the other one is more unknown. Or how would you say that better so people understand the difference between what
Yeah.
classic physics is?
Okay. Yeah. Classical physics is just large physics, so it's kind of like the physics of like relativistic physics has to do with the sun and the earth and the galaxies and the universe, and that's relativity, Einstein's relativity, and those little gravity curves that you see around the sun and planets. That's relativistic physics. Newtonian physics has to do with an apple falling from a tree and the speed at which it falls, all the forces involved. Often there are problems involving a frictionless inclined plane and rolling something down it. That's your basic Newtonian physics. And then the quantum physics would be the physics of the quanta, which is a word that Max Planck came up with to describe the very smallest possible building block of everything that reality is made of. And that's what it was supposed to be. What actually happened when they're studying the smallest so-called building block is that they found out this little particle, quite a bit of the time, does not behave at all like a particle. It acts like it's a wave, just with nothing that you can measure. And there's all kinds of uncertainty involved. And it's just waving along, doing that wave-like wave function thing. And that was the beginning of the weirdness. And then it just got weirder and weirder. So involving things like a future decision can affect the past. That's definitely part of quantum physics. An observation itself can change what happens. Like what? Two observers.
That the double slit experiment? Is that how all that came to play?
How good can it get? Check us out on Secure 65 Health Plans to find out more.